All right, thanks for everyone for being here. Thanks for that great introduction. So today we're going to be talking about beer oxidation and all parts of sensory and prevention, and we're kind of going to dig into the science a little bit starting off at the beginning of the talk.
All right, first of all, Martin did a better job introducing ourselves than we could, but we're really interested. This is a huge problem that we face in brewing. And so here's some data we collected yesterday from our colleagues who judged at the second round. And I asked folks, 8 judges on 8 flights, score up the number of beers that were oxidized. And so this is supposed to be the best judging competition. Homebrew, I mean, this is the best of the best. What we tasted yesterday, and 40% of the beers that people tasted were oxidized. And these are styles that are not supposed to be oxidized. We're not asking people in the old ale, is it oxidized? Yes. And so this is the problem here. Is this is a really, really common flaw. It's a common flaw for homebrewers, and it's a common flaw for commercial brewers. We're going to have one of these. We're going to have one of the commercials in just a second. And so what do we mean by when we say oxidation? So we're going to go just a tiny bit of chemistry here. I promise it'll be short and it'll be painless, and we'll stop in just a few slides. And so what do we mean by oxidation here? And so carbon has 4 electrons around it, and it shares these electrons with other elements to make bonds. And it can lose these electrons, it can give them away, or it can gain them, in which case it's getting so-called reduced. And so oxidation is a chemical term, okay? It's a chemical term, and it's also a term that we use just to describe these various flavors. But what's happening is that we're changing the chemical bonds, the way carbon bonds with other molecules, to make new compounds that we don't like in beer, that you soon are going to get to taste. And so carbon does not share these things equally. When it makes its own bonds, it shares them equally. But when it bonds with hydrogen, the carbon takes the electrons away from the hydrogen. But when it shares with oxygen, the oxygen is super greedy. Oxygen is one of the most electron-loving elements out there, and so oxygen takes them away. And so a carbon molecule with a lot of oxygens in it tends to be fairly highly oxidized. And so we can have different oxidation states for that. And so I've plotted out. So up on the upper left is methane. Methane is what I use to heat my boil. Probably many other people do here too. That's natural gas. That's the most reduced form of carbon. The most oxidized is CO2. Up in the upper right-hand corner, that's what comes out of your airlocks. And so that's a highly oxidized. That's not even organic. And the one down below is what's in your hands right now, and soon to be in your blood. Is ethanol, and probably it's still in your blood from last night. But anyway, that is a moderately oxidized compound. So we have mostly reduced, completely oxidized, and in between. And in the presence of oxygen, compounds tend to want to go towards oxidized. And so here's the process, and we go from an alcohol to an aldehyde. So that's a really common form of oxidation, is to go to these aldehydes. And so we go to aldehydes, and aldehydes are really strongly flavored compounds, and not often good ones. And then that can oxidize even further to a carboxylic acid. And so we could go from ethanol to acetaldehyde to acetate right up there. Acetic acid would be along those steps. And so that is chemically what is happening. There's many molecules that get created, and these things change through time in your beer. And so here's a plot from an old paper. I'm not going to go through all these, just showing these changes through time in beers. And this bottom quote is really good from Charlie Banforth. Too often attention is paid to relatively few flavor notes associated with aging, and of these, cardboard or wet paper is the most frequently cited. This is hopelessly limiting. There's lots of other things going on in your beer, and Andy's going to talk about those.
Awesome. So one of the big reasons I wanted to be here today was because there's numerous times I've sat judging in different forums, whether It's for Craft Beer and Brewing Magazine. Shout out to Jamie. I help judge on their panel. I've helped judge homebrew comps and stuff. And there's so many times when you sit down, and one example I had was like we were judging a Saison, and one of the other judges was telling me how much they liked the honey character. And I was looking at him like, there's no honey in this Saison. That's oxidation. And because of the examples of some of these beers we get at the store, it's hard to get fresh examples. So a big part of what I want to talk about today is that oxidation is more than just papery. There's a lot of different flavor compounds that'll be present. You currently have fresh fat tire. We'll get into what that tastes like, our definition of what that should taste like at the brewery in a second. Don't drink all of it because we're going to pass out an oxidized one here in a minute, and it'll be nice for you guys to compare those so you can tell us what the differences are between the two. But the other thing too is that oxidation doesn't necessarily have to be a flaw. In some styles, we mentioned Old Ale already. Some of these oxidized compounds can be complementary. Barley wine, Old Ale, even something like an Imperial Stout, you might want a little bit of that sherry notes or something like that. So, but if you're getting sherry notes in an IPA, probably not what you're going for. So. Good man. So we're going to talk about some of these oxidized aromas and the precursors to them. So, like I mentioned, certain styles tend to oxidize in different ways. Big malt, heavy focused beers tend to get more of that sherry, raisin, dark fruit character. A lot of that comes from different specialty malts, especially caramel malts have been known to oxidize very ungracefully. Fat Tire has some Caramel 80 in it, and it's one of those beers that when it oxidizes, it definitely comes out more in those fruitier. Wheat beers can actually develop a off flavor that tastes something like mashed potatoes or dog food or potato chips. We'll be talking about that in a second. And malty ales, also again, Fat Tire. I personally get Golden Grams. I don't know if there's a chemical compound name for Golden Grams. Haven't looked that up, but honey for sure. And then papery tends to be, although it is very common and has an incredibly low threshold and it's in lots of beers, it's definitely the dominant off flavor in more like the lighter lagers. I remember getting an Asahi Super Dry at a kind of dive sushi place in Hawaii, and it just was straight cardboard. So it's definitely not good when you get it, but like we mentioned, there's a lot more going on than just that wet cardboard. And finally, one that been learning a lot recently is beta Damascenone, or just Damascenone. It's kind of a red berry, green things turning brown, or applesauce, stewed apple character to it. And it is from hops, and it's proportional to the amount of hops that were used, especially dry hops and things like that. So we'll get into each of those. Ooh, here we go. Talked about it a little bit. Already kind of touched on this, but a lot of these off flavors are from the raw materials, right? So not every beer is equal. Not every beer oxidizes the same way. Different inputs, different outputs. So getting into these a little bit more, methionol was the first one we talked about, or methionol is the mashed potato one I mentioned already. It is an aldehyde. You'll notice a lot of these are aldehydes. It has a pretty low threshold at 4 parts per billion. And if you want to get more into the chemistry of what causes that, this Strecker degradation of amino acids is pretty interesting and way over my head. But that's really common in wheat beers. It's something that I've kind of gotten used to, not even knowing what it was. And then as soon as I learned that it was a thing, I'm kind of like, oh man, that's mashed potatoes. All right, that's kind of gross. Here's everyone's favorite, trans-2-nonenal, papery. It is also an aldehyde. And it is, most common in lighter beers. It's in lots of aged beers, but it sticks out a lot in the lighter beers. Another thing too that I want to point out is at our sensory program at New Belgium, we're really big on giving an array of words to describe things. So like, for example, I'll get it into in this one, lipstick. A lot of people get it as lipstick. So just because someone says something, they get it as cardboard, you may or may not get it as cardboard. You might get it as something different. That lipstick thing definitely comes through. I'm definitely a lipstick connoisseur, if you can't tell. Damascenone, this is a good one. It's actually a really commonly found in grapes and is one of the primary flavor compounds in bourbon. But the descriptions up there, red berries, tobacco, green things turning brown, sweet apples. This is really common as if you bought your favorite double IPA over at Surly and then you brought a can home and forgot about it on your flight and left it out on your counter and cracked it open a few weeks later and it isn't quite the same, good chance there's a fair amount of beta-damascenone in there. Acetaldehyde, you probably think I'm insane for putting this up here, but not only is it the precursor to ethanol and alcoholic fermentation, but then it can be oxidized back into acetaldehyde during oxidation. So not incredibly common, but kind of an interesting one to talk about. And this is another one I like to talk about where it's not just green apple. If you don't get it as green apple, you're not wrong necessarily. I personally, it reminds me of carving a pumpkin for Halloween. I know Bob mentions he gets it as kind of a latex paint character. So it's another classic. And there's other common things that we find ourselves writing that because it's such a complex process, we don't understand it all. We can't always put chemical names to these. But almond, actually the chemical name for that one is benzaldehyde. Sherry, honey, sometimes a candy-like character from the malt or hops. Again, I'm partial to golden grams. Leathery, which also can come across as like a woody or a chili beer character almost. Mercaptan, which just smells like dirty drains. And last but not least, dullness.
Yeah, so dullness is really, really common. And so a lot of times when judging, and this was yesterday, this was a horribly oxidized beer we were drinking. I won't say what style. And there's my colleague next to me, co-judging, and trying to figure out, why can't I smell this beer? And it's because it was really oxidized. And so if you smell a beer and you think, wow, do I have a cold, or I just don't get anything, or what am I supposed to be getting? I like to joke at a competition, I can see oxidized beer all the way across the room, because people are sniffing it, looking around, sniffing it some more, staring at the bin, sniffing some more, maybe excuse. And so so that's the fault of the beer. It's not your fault. And so it's a really common thing just to not have that much aroma. So not only are we getting bad things in the beer, like T2-nonol, but it also removes a lot of the aromas that we are coming to expect. And so the oxidation changes the chemical constituents of these aromas, and they're not nearly as strong.
This is another quick anecdote relating to dullness overall. We did a study at New Belgium with different types of crown caps, including different barrier materials and some that scavenge oxygen. And as the beers with oxygen scavenging crowns started to age, our panel actually couldn't even tell at some point what the original beer was. All the aroma was being stripped out of the beer by the cap, not just the oxidized compounds. So at New Belgium, we don't use oxygen-absorbing crowns. I know it works for some breweries, and there's different styles out there, but we found ones that help the beer age poorly, but then we know the beer is aging, and it's not just nothing anymore. So as a panel, that's something we found that we like and don't like. But if you're finding that your beers just kind of get super dull over time and you are using oxygen-absorbing crowns, next time you bottle some, you might try doing a mixture of caps and seeing if you prefer one or the other over time.
Okay, so just besides the oxidation, there's other things that can happen with beer. One, storm under lights, and it's a very familiar aroma to nearly anybody. The skunky aroma from mercaptans. You will change the color of the beer. I'll give you an example of that in just a second. Loss of foam, and then formation of haze, particles, or chunks. And so this is one of the reasons why really old beers will sometimes gush, because those chunks form nucleation sites for the CO2, and out comes all the CO2 out of a highly carbonated beer. So that's a typical aged problem.
And to butt in real quick, you'll probably notice actually I was pleasantly and unpleasantly surprised to see that our aged sample here is actually fairly hazy, and Fat Tire's bright beer when it's fresh. So a good example. We just tapped that keg today. I had no idea exactly what it was going to look and taste like, but definitely an example of that, breaking down visually a little bit.
All right, what's going on with these beers right here? Anybody? Yeah, oxidation. That's the same beer. That's New Belgium Pilsner. Sorry. And that's what I did. As I took one, didn't do anything to it. One, I opened and just sort of blew out the headspace and then recapped it. And the other one, because I was really interested in getting it dark, I thought, well, I'll sparge it with pure oxygen. So I did that. It turns out I didn't need to do that. All we need to do is just take the cap off of the, And
how long was that?
that was 2 weeks. 2 weeks. Warm stored, not hot stored, but just warm stored. So that was 2 weeks. That was what probably happened in it would happen in just a few minutes. And so that's what I did right there. It's just, and the flavors, first of all, it was disgusting. Cherry almond, low paper. I did this at a party because I wanted other people to try it, and they were like, no, that's gross. And so what was really interesting to me is that the one I sparged with oxygen was not really that much more oxidized than the one. All we had to do was open it up. So try this at home. Open up a beer, preferably a light beer. Just sort of replace the headspace with air, blow into it a little bit, and then cap it back up, and then see what happens over a couple of days. And that gets really oxidized. And that was just the headspace of air, okay? Just a headspace. And so think about that. We'll come back to that when we talk about how we package. But you package with a headspace of air, and you will have that gross brown beer on the right. Okay, now you guys get to tell us.
Excellent.
Yeah, and what's cool is that this fat tire, this isn't what I did to that Pilsner the other day. So this is well within what you're going to get when you just go buy beers sometimes. I've had many commercial beers quite a bit less oxidized than this one. So we're sort of making fun about how gross it is, but in fact, this is maybe what this is pretty common, I think.
Yeah, for sure. And behind me, this isn't specifically for Fat Tire, but in general, as our panel notes aged beer, so we shelf life study all of the beers we make, whether it's a one-off or something brand new. Obviously, we're always looking for ways to improve the shelf life, so we don't have to go through this, but we study bad beer a lot. And these are a lot of the compounds. These are some of the flavors and aromas that our judges note regularly when they're describing an aged beer. So some pretty gross stuff up there. The cola one's pretty interesting. I definitely like that descriptor too. Soy sauce is more common if you have yeast autolysis, especially in darker beers. I can't say I've ever got potpourri, but I believe someone said that once upon a time. All right, cool. We're going to talk a little bit about trying to keep DOs down. So we're specifically focusing on packaging and transferring beer. At the end of primary fermentation, you're going to have essentially zero oxygen in your beer, right? It's been producing CO2, it's been bubbling and scrubbing it all out. From that point forward, oxygen and heat are the number one and number two enemies of beer. The more oxygen you have, the more staling compounds you're going to create over time. The more heat you have, the faster that's all going to take place. So this slide is super dense and not meant. This is kind of an overview of how often we're monitoring the dissolved oxygen in New Belgium. And the short version of that, if it's too long and you didn't read it, is that we are maintaining an average DO below 100 parts per billion all the way up until packaging. Even once after the filter, if we get to a point where the DOs are high, that beer goes down the drain. We do not put out-of-spec beer into our bright tanks because then it's going to age poorly, and it's a lot harder to get bad beer out of the market than it is to keep from putting bad beer in the market in the first place.
Just to put that number into perspective, if you were to take dissolved oxygen at saturation in water is 10,000 parts per billion. So 1/100th of what would normally be there. So a glass of water on a desk is going to have about 10,000 parts per billion.
Yeah, it's an incredibly, incredibly low number. In fact, one of the things we do at the brewery to keep that number down is when we push beer around with water, we actually deaerate that water first so that boundary between the water and beer doesn't pick up extra oxygen. But the more you play with something, the more you do things like dry hopping, transferring, centrifuging, all these things, you have a chance to introduce oxygen. So then we're going to go over here. So bottle filling. This happens really quickly. We run at 715 bottles per minute. We pressurize the bottle with CO2, we pull vacuum, so we completely remove everything, pressurize it again, vacuum second time, pressurize it a third time, and then we fill it. Our TPO limits that'll stop the line for a forced carbonated beer is 250 ppb. So if we're above that at any point, those bottles get knocked off and they get recycled, crushed and recycled and pulled off. We'll actually stop the line, make sure things are in spec before we get going up again. And then we actually do add yeast back to some of our beers, and those have a little bit higher DO limit. And we'll get into that more a little bit later on, but yeast is an excellent scavenger of oxygen. So a quick little thing. This is a quick short video clip just to show you. Oh no, go back. So that's what 715 bottles a minute looks like. That, pretty ridiculous. That one in the center is where we do all the filling and purging and all that stuff. It's 109 heads that around there, and more than 2/3 of that space of that carousel are just for pressurizing and getting the CO2 out. The last third is for actually filling the bottle. So you can imagine how quickly that happens. Since I have another one, I'm just gonna stand back here for a second. Oh yeah, we already watched that. Canning is very similar. We pressurize with CO2. Unfortunately, we can't pull a vacuum on a can because it will cease to be a can. It will turn into a... So instead, we just pressurize it, release the pressure to atmosphere, pressurize it again, do that similar, and then we try and seam it on foam as best as possible. Another quick video clip. You'll notice that between the filler and the seamer, the cans are just open, and the white part that looks like a lid is just foam. So cans also have a much larger diameter opening, right? So there's a lot more risk of getting oxygen in cans. It's a lot harder to fill cans with low DOs than it is to do bottles. This one doesn't run quite as fast, but it's still pretty sweet. Dang it. Seamer. I want to say it's like 200 or 300. I can't remember off the top of my head. That's a good question. All right, back to Bob.
Okay, so what can we do to help prevent? And so one is yeast. And so yeast can prevent and even reverse oxidation aromas. And it's because yeast they're facultative anaerobic organisms, but if you give them oxygen, they're super happy. It's like, okay, great. And so then they take the oxygen and they do complete respiration, which is what you guys are doing right now as opposed to fermentation. So they will scavenge out all the oxygen, and they'll do things like they'll reduce aldehydes back to alcohol. And so which is a good thing from a flavor perspective. And however, it can lower some good aromas. You guys don't add that yeast back in.
Yeah, we found, one thing I meant to touch on previous slide is we actually add yeast back to some of our cans, especially because of the higher risk of DOs. Back in the day, our old can line was actually meant for canned food and not for canned beer, and we adapted it to make it work, but our DOs were pretty terrible. And we do pasteurize our beer, so we don't have the benefit of already having living yeast. Instead, we add a controlled amount of yeast back into the package right when we do it. We actually, if you were here for the previous talk, we talked about adding dry yeast back. That's exactly what we do. So we mix up a slurry of dry yeast on our can line and dose it into the cans at a very controlled rate. We started originally just doing that for Fat Tire, but as we've extended the amount of beers we put in cans, Dayblazer gets that as well as our lower alcohol IPAs that tend to have very short shelf lives. And then we also do it for our Belgian beers on our bottle line. Abbey and Triple get. We harvest yeast from those beers and then add a controlled amount back into the can. So it's not getting a true bottle condition, but it is getting living yeast added to it. And they do get warm stored for a short amount of time to kind of touch up the CO2 and kind of polish it off.
All right, so here's a really cool study. And so these folks took 1-year-old beer that was oxidized, so kind of like what we just had, maybe more oxidized than what we just had with that Fat Tire. Then they added yeast and sugar to it, and they capped it up and let it sit for a little while, and then they tasted it again, and a lot of the flavors, the oxidation flavors, went away. And so here are the data for this. So the gray line is oh wow, I did that backwards. What do you know? Spacing out. Okay, I'll explain it. The gray line is the old beer, and so there's a lot of these flavors that they find, these oxidized flavors. Maillard reaction, Madeira is sherry. That's a classic one. Cardboard there. Ribes is an interesting one. It's blackcurrant leaves. And How many people know what that tastes like? Yeah, I don't either. I was out on a mountain bike ride just the other day, and I found ribes. It's a plant that grows everywhere in Wyoming, in the mountains, and I smelled it, and it was just kind of oniony and gross. And I'm like, I don't get this. But in fact, it does make a mercaptan, so that's where the oniony flavor is coming from. And so what we have here is the gray line is what it was before they added yeast, and the black line is after they added yeast. And all these flavors shrunk down, these oxidized flavors shrunk down. So they were able to reverse oxidation by adding fresh yeast to beer. So pretty cool. This is an experiment. We should try this sometime. Let's take some old beer and then uncap them and add some yeast and see if we can reverse these flavors. And so, pardon? They don't say. And so when there's Lager A and Ale A, in these brewing studies, they often don't give brand names when they do this. So this was in Belgium. So if they're using a big marketed beer in Belgium, it's probably Stella Artois or something like that. But they don't really say what they are. They never do.
We're getting pretty close on time, so I'm going to keep us moving ahead. A lot of this stuff here, a lot of you I'm sure are probably already doing this, but especially cold side, doing what you can to minimize CO2 pickup, purging out your secondaries, or if you're doing a primary fermentation and you aren't dry hopping or adding fruit or anything, consider skipping a secondary altogether. One less transfer, one less chance to pick up oxygen, and a little bit of that living yeast. Although it might give you a little bit of haze in your keg for a first keg or two, it will help it age a little more gracefully in there.
After the primary is completely done and the beer is stable, yes. And so, but that I'm not necessarily like I'm now going on some of my beers are just going straight from the primary to the keg and skipping a secondary if I don't, I just did that for a beer. Oh gosh, it'll be longer than that. I don't mind keeping beer in the primary for 10 days. I don't pick up autolysis flavors at all in my beers when I keep them. But when you fill, the key is to keep the headspace out. Keep the headspace out. And so if you use a beer gun, purge with CO2, fill it up and cap on foam. If you're capping on foam, that foam is all CO2. There's no air in there because it's CO2 degassing and coming up and filling up that. And that's going to be the way to make sure that you don't trap any air in. But we'll show some data in this. So in just a minute. So you want to cap on foam when you do this.
So we did a quick test for fun, and we have a pretty sweet DO meter and total package oxygen meter at New Belgium. And so I decided to fill beers like I might consider filling beers at home and collect some data around that and see how much it makes a difference. And so this was our first method. This is how we fill growlers at the brewery, and I just filled beer bottles like it, filled it as high as I could with that little hose, then pulled the hose off, filled it as close as I could to the crown like you would a growler, or I've seen pretty commonly for comps to try and keep your headspace down to a minimum. That's what they actually looked like before we ran them, so you can see very, very high fills. But fill heights aren't worth points, so no worries there. Then we also tested with beer gun. I'm sure some of you have one of those. The first one is actually a little bit of a low fill, and we also didn't purge these with CO2. And then the second one was a pretty good fill height, and these were properly purged with CO2. That's what the machine actually looks like. So it brings a lance down and spears the cap, measures the DO in the liquid, measures the oxygen in the headspace, and then gives you a bunch of data about that, which I don't want to know. It's not cheap. It's not something I have in my basement to check DO on homebrew. That's why I wanted to share this data to try and kind of bridge that gap between what we have and data that might be interesting to everyone in this room. So, you want to talk about this a little bit, Bob?
So here are the data, and so we have. I did do this one right. We have the beer filled from the tap, the gun without CO2, the beer gun with CO2, and then Inspect New Belgium. On the vertical axis over there is total packaged oxygen. That's the total amount of oxygen in the beer divided by the volume of the beer. So it's as if all that oxygen were to go in saturation. Because what happens is right after you fill a bottle, some of the oxygen's up in the headspace and some of it's in the beer. And so equilibrate it, measure the headspace, and you can calculate what's going to go into the beer. And And then also is that there's high variability here. So on that axis is scaled on a logarithmic scale. Okay, so New Belgium is wanting to keep theirs down below 200. 250, and you can see that the New Belgium is right at that spec. Notice that the beer guns can be quite a bit lower. They can be down near 50. So it is possible, and to be able to get low dissolved oxygen at home during your filling. Yes.
Yeah, that was just a quick one to see more. I expected it to be terrible, and I was like, hey, I'm going to a party, whatever, or maybe I didn't want to break out my bottling gun and want to fill a beer for comp right off my kegerator. That's kind of what I was trying to recreate with that one.
But what's interesting is that two of these points are high and around 500, and Andy's like, oh, I have no idea what happened when I did that. And so it'd be tempting to say, well, that didn't work. But in fact, that did happen. I mean, the machine's not going to lie. If it reads 500, it means there's 500 in there. And so what this says is there can be, and this is going to be what separates us as homebrewers from that bottling line in New Belgium, is that we're going to have occasional slip-ups. We're going to have high DOs occasionally. And so I wasn't aware when you filled them. So just maintain your process to be really consistent and look from bottle to bottle. A lot of times when I'm judging if something is like horribly oxidized, I might say, well, hey, let's just try a second bottle just in case that bottle cap didn't seal right, or they capped on a pile of air. But if you cap on a pile of air headspace, that's it. Your beer is going to be brown and gross like that Pilsner. So there is some variability. So so the message here is it's possible for us to get very, very low. Maintain your process to try to stay there.
2-3 seconds. Give it the question was, how long did I purge the bottles? 2-3, quick count, have a sip of beer. About that long? Yeah. No, this was just kind of a quick, I wanted to just get some raw numbers out there, not be super, super scientific about it, and kind of open up the idea of where we could go from here as far as, I'd love to test different fill heights, different times of CO2 purge. There's lots of opportunity for more testing on this, but this was kind of a quick, I want to throw some data together and see what happens.
Well, I'll tell you, if we were to try to do this statistically, with that kind of variability, we'd have to do a lot more bottles. So there's not enough bottles on there to do statistics on.
And I should probably not be drinking beer while I'm filling bottles.
Yeah. And I try not to do statistics while drinking beer.
So a lot of this is kind of, conditioning and storage, the last element. It doesn't matter how good you do if when you store it, you don't treat it well. And a lot of this stuff, again, is review, but, keep it cold, keep it out of the light. A little bit of yeast definitely might help it age, and especially if you're brewing in the lighter styles and you enter a beer into NHC and it makes it to the second round, just preemptively brew a second batch, because a lot of the styles we found that were noted as oxidized were in the lighter categories that don't age as gracefully.